Alright, cool. So last time we really just went over all of the 2D stuff. So I'll start off by making a 2D sketch and picking a plane. So really what we went over last time is just all the different types of shapes. So lines, circle, arcs, and rectangles. We also learned how to modify the shapes. So specifically how to trim the shapes, offset the shapes, and rotate the shapes. And then we also learned a bit of patterns in 2D, so rectangular and circular patterns, as well as mirroring. And then we learned a bunch of constraints. So I guess I'll just, briefly go over some of these again. So once again, I guess a line looks like this, right? You want to give it 2 parameters, right? 2. And if it's black, that means it's fully constrained. You press escape in order to exit, I guess, the line tool. Circle is the same thing. You want to give it a certain diameter, let's say 1. Notice how this is not fully constrained because I did not set it, I guess, exactly at the origin. So that's why it shows up purple. An arc is basically the same thing, and then I'll just do a rectangle. Let's do a 2-point rectangle, why not? Like this, 2, 1, there. And notice how the rectangle there is black because it's fully constrained. So that's really basic stuff, lines, arcs, circles, and rectangles. Let's see, I guess I can go over the modifiers. So I guess one of the parts we did was trim. So if you want to create maybe some sort of shape like this, like that, you can use the trim tool to kind of make more complex shapes by kind of combining simple geometric shapes like circles and rectangles. So you can do something like this, 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 and notice how you made, I guess, a more complex shape using the trim tool. Right? You can also use offset to make smaller or bigger scalar versions of the shape, right? So I don't know, 0.5. And then you can also use rotate and split and scale. Those are all things we covered. Patterns. So I guess I can go over rectangular patterns. So let me create a rectangle. Alright, let's make it here. Alright, and then I create a circle, like maybe right here. I can dimension it. Alright, there we go. I can create a circle like that, and I can dimension it. So one of the things we learned was also dimension, which is a constraint. So maybe setting the distance between here and here. Then setting the distance between here and here. That's 0.5. Then we can use the rectangular pattern tool to make patterns. So for example, you can select what you want to, I guess, make an array out of, and then you can give different directions. I want to make it go in this direction, and then for this one, I want to make it go in that direction, and let's make 3. And then you can make a pattern like so. And you can do the same thing for circles as well, which I think we'll talk a little bit more today, especially when we go into 3D shapes. And then the last thing we talked about was a bit of the constraints. So, I guess tangent, vertical, horizontal. So I guess I'll go over a few of them. So here I have a line, and here I have another line, like that. And I can use a constraint function to make both of them parallel. There we go. Maybe like this line and this line I can use to make them parallel. I can also use them to make them perpendicular, vertical, and horizontal. And let's say I have, I don't know, a line like this, and a circle. I can use the tangent constraint to make them tangent to each other. Oh, I wonder why that's not working. I guess I can select anything else. Like, see how that's tangent to each other. And that's basically, I guess, a general overview of what we did. These 4 things, and these are all in the 2D sketch, so what we'll talk about more today is going into these things in a little more depth in the 3D by extruding them and using revolving and sweeping and all those different functions. So I guess that's a general overview.
Okay, so Chris just covered what we went over yesterday. Now we'll like jump into the homework check-in. So you guys email me like pictures of your homework, so I'll like pull it up and then just like walk me through what happened. Okay. Let's see. Here, Ashman, this is yours. So you just wanna walk us through how you created this? Can you guys hear me?
Yeah, we can.
Yeah, we can.
Yeah. Is Ashman on the call? Okay, I don't think he's here right now. Next person was Arnold Sinha. Is Arnav on the call?
Yeah. Hello?
Yeah. Yeah. You want to just walk us through what you did over here?
So it's basically a sunflower and like it's framed. So for the
Okay.
circular pattern, it's like the leaves and the sunflower. And then the rectangular pattern is the frame.
So do you want to like tell us how you like what you did first, and then like just like walk us through the steps of how you did it?
Okay. So I created a rectangle at the bottom, like the base.
Okay.
And then I mirrored it on each side. So like,
Okay.
yeah. So it creates that. Then I created a line, like the stem of the sunflower.
Mm-hmm.
And I drew a circle with a
Okay.
radius of 30, I'm pretty sure.
Yep.
Yeah, or diameter of 30. And then I used the circular pattern and I created leaves to the sunflower.
Okay.
Yeah, and then I created a border around it using the rectangular pattern.
Okay. You see like there's a circle going through the centers of these like the circular pattern.
Yeah.
So did you use that for the like did you select that for your like is that what it's following?
Yeah.
Yeah, so because that's not actually part of your drawing, you're just using that as a reference, right? I would select that, and on top, I don't know if it's in the picture, okay, but on top, we went over the construction tool. So because it's not part of your actual drawing, you should select that and click construction. So it will come as a dash line. But
Okay.
yeah, everything else seems pretty good.
Okay, thanks.
Next person was, I think Arjun. You want to walk us through
Yeah.
yours?
Hello?
Yeah, we can hear you.
Yeah, so I started with the lines on the outside. I drew the lines on the outside and I used the mirror tool to make sure they were the same distance apart from the center. And then I used the offset tool to create the outer lines, so those would be the same distance too. And then I just used a normal line tool to draw those diagonal lines. And then after that, I drew a square on the top left and used a rectangular pattern to repeat it throughout the whole thing. And then afterwards, I just use a circular pattern to repeat the circle through. And then I just reshape them.
Did you draw the diagonal lines for a reason or just for like design purposes?
Well, yeah, design purposes.
Okay, cool. So did you say you drew these two rectangles by like separately?
No, I drew like a square first, like
Okay.
the four lines on the inside, and then I used the offset tool too.
Okay, perfect. Did we go over the offset tool, or did you do that by yourself?
I'm pretty sure we did, but I'm not sure.
Okay, that's good. Yeah, good work. Manav, you're next. Oh, hold on. Okay, cool. You want to walk us through yours? Manav? Is Manav on the call? Can you hear me?
Yeah, I think he's on the call.
Okay. I think Manav and Ashmit. Ashmit, are you back?
What? Yeah, I submitted. I emailed it to you.
Yeah. Here, you want to walk us through yours?
Sure. Yeah.
Okay. Go ahead.
So to start, I kind of just drew like a circle, so it's in the middle,
Okay.
and then I just created like that one square on the side, and I just used the circular tool, and then I just copied and moved that square into the interior of the circle, and just like used the circular tool for like 100 of them, and then
Which one are you talking about?
so there's an inside circle, right? And so
Yeah.
there's on the outside, I just created one reference square, and then I
Okay.
just used the circular tool to make it wrap around the circle.
Okay.
And then I used that same square, and I just moved it to the inside of the circle, and then used the circular tool again. And
Okay.
then I just made pentagons. I just made one pentagon, and then I just used the rectangular tool, and I just reflected it on a center line, and I put it on the side. I just made it. Yeah.
Okay.
I just made the boxes and reflected them, and yeah, that's basically it.
Good. One thing I wanted to point out for all of you who sent it to me, you guys all your sketches were all black, which is a good thing. That's one thing I want to make sure everyone knows, that if your sketches are not completely constrained, they will not be black. So your drawing is not done yet. So great that everyone got it. I don't think Manav, I think we're missing you. Do you wanna focus on you back?
Just before you guys go on, I just want to remind the design leads to make sure you guys fill out your. I just want to make sure you guys fill out your what's it called? Your attendance. Yeah. So make sure to do that, because
I
you
think
guys
Kush
have to
got
like
that,
it.
right? Kush, you got that?
Yeah, I got it.
All right, so
Okay, cool. If Manav's not on, then we can move on. Okay, I guess we'll come back then. Sonnet, what do you have next?
So I was planning on going over 3D stuff today, but before we get into that, I was thinking we should show them one of those robot review videos. So do you want to show one of 118's robot review videos so we can talk about that before we get straight into CAD again?
Yeah, sure.
Yeah.
Sorry, give me a second. Okay. Whose reveal video did you want to see?
I think 118 works. Also, maybe we can see your screen right now.
Oh, over here.
we'll be asking you guys to share your thoughts out afterwards. So try to make sure to pay attention. Maybe take note of something. So we'll go around and share all afterwards.
Wait, can you guys hear the computer audio?
No, we
No,
can't.
Oh, okay, because the music's kind of hype. I want you guys to hear this. Wait, I don't know how to. Hold on. Okay, anyways. Okay, that was about it. Basically, that was the game that you guys saw was a practice field for the 2020 game, Infinite Recharge, and it just like displayed all the things that the robots can do. So here, I'll show you guys that again because it's not too long, just to make sure that you guys understand. Okay, yeah, so they basically just like walked us through what the robot can do in regards to the game, right? Is there anything notable you guys saw in the video? Do you guys want to talk about?
Yeah, guys. So especially during the game, so can you mute yourself? Yeah. So especially during the game season when we're working with fabrication and other people to come up with ideas for the robot, design teams will really be leading like the whole initiative. You know, since you guys are supposed to, this is supposed to be your area of expertise, and you guys are supposed to know what you're doing in this particular area. You guys really need to be pretty open and vocal about everything. So me and Drew aren't gonna call anyone's names, but we want you guys to speak up and just like share what you saw. Especially since
Son and Groove, guys, have you talked about any mechanisms yet?
yeah, we have.
When?
Yesterday.
We went on the drivetrains.
Only the
Why?
drivetrains?
Yeah.
Yeah.
Do you guys talk about shooter or elevator or anything like that?
No.
Not yet.
Then there isn't any point in trying to ask them about what they saw in the video since they don't know much of anything other than the drivetrains that you guys showed them. That should be something that we should be doing after they've learned how to CAD, and then we can show them that and then pair that up with game strategy for the kickoffs.
Yeah, we can walk through that.
So
Well, they
just go into
could
the
point out
pattern.
like things they notice, like what the robot just does, like on the
Sure,
field.
but I don't see that as like Sonic trying to go for the whole strategy for kickoff. That's not exactly gonna
Wait, I'm
work,
not trying
especially
to go
this
there
one.
though. I'm just like trying to see what they know so far, especially since we do have a bunch of veterans here that they can talk to.
This is meant to be more for the rookies right now. Veterans should be in. Yeah, I mean, I was gonna say that next actually, but veterans join the other link just so I can talk to you guys about the other that stuff.
Did a cool just leave?
I'm pretty sure he joined the veteran meeting, but I like just joined from the fab meeting. What was he talking about? You wanted you guys to go over mechanisms before you guys did something? What were you guys doing?
We played a video for them and like asked them to like analyze stuff from the video.
Oh, like strategy-wise, right?
It was like a robot
No,
review
just like
video.
yeah, just like talk
Oh,
about
interesting.
what they
Okay.
want.
Yeah, okay, that's fine. That's fine.
It was like a general like, oh, what do you see the robot doing type. But I think Akko wants us to go into specifics with the
Mechanisms,
mechanisms.
yeah. Okay,
So
that's fine. Just go into, I mean, you can just like, if you guys are using like videos of robots or pictures or something, kind of just zoom into them for now, because I mean, you guys don't need to go super in depth right now, because I feel like this is kind of design and strategy. So if you guys want to go more into depth in mechanisms tomorrow too, that's okay. It's you guys' choice. But if you guys are doing like pictures or videos, just zoom in and just like point out everything.
Yeah, honestly, Drew, if since the cool doesn't want us to talk about that video, we can just show the mechanisms. Do you want to do that before we do catting today then? Because today catting's gonna be a little longer.
Do mechanisms first.
Yeah. So Drew, I think we should start by showing, okay, so we already did drivetrains. So drivetrains are one of the, like, major things. After, guys, just as, like, a side note, after boot camp, we will be doing, like, a CAD through of a more intensive project. We're going to be doing a West Coast drive together. So it's sort of imperative that you guys, like, remember the information we did yesterday. We will be reviewing it again. So I think in terms of the infinite recharge robot, I mean, we did talk about drivetrains, so does anyone want to share what they like noticed in that video about the drivetrains or anything like that? No one has.
I didn't notice anything about the drivetrains, but I saw that all of the goals were at different heights, which means that the shooter should probably be adjustable.
Yeah, that's a really good observation. Anyone else have anything?
I'm not sure if many of you guys have seen our last year's or our robot for infinite recharge, but the 118, I think, their robot's really similar to what we had before.
Sonic, you have that cat file for our robot. We can walk into the different aspects of that and like the different mechanisms it has.
Yeah, I don't.
My file's been corrupted.
Robot right now.
Okay, here, let me find a picture then. Or we can just walk them through the robot they saw in the video.
The robot design video?
The robot that they saw in the video, like the 118's robot.
Yeah, that works too. I think that's honestly better. Or
Yeah.
actually, I have a picture. I don't have a video, but I mean, I don't have a CAD file, but I have a picture. Do you guys want to see that? Okay, I'm gonna.
Yeah, just like walk them through the different mechanisms. Yeah.
Okay, guys. So this was our robot for the 2020 season and sort of 2021 because it was like sort of a similar game. But just looking at this right off the bat, do you guys notice anything about the drivetrain, what it might be?
It might be like a four-wheel drivetrain, I'm pretty sure. That's what it looks like to me.
Oh wait, sorry, I didn't realize it was muted. What did you say?
It looked like a four-wheel drivetrain from what I see.
Okay. Yeah, so you see the two here. Okay. Anyone
It,
else have any
it
ideas?
looks like the drivetrain where the wheels can like spin, like it can steer.
Yeah, yeah. Okay, that's definitely correct. Anyone else have any ideas? Okay, guys. Well, I actually told you guys this yesterday. I don't know if you guys remembered, but this is the Swerve Drive. So that means, like Sanjin said, there's four like little pods here, right? And then every single pod has to have like two whole motors just dedicated to that pod. But it gives us a lot of pushing power and maneuverability, so the best of both worlds. This is actually our team's first time in quite a while doing a swerve, so this was super exciting. Okay. So do you guys notice anything about the motors? Okay, guys. So these little ones here, these are the Falcons that I talked about last time. The new ones that Vex came out. But I think these are the mini sims that we saw yesterday. So does anyone want to just go ahead and move and talk about, like, give everyone a, since some people weren't here yesterday, a summary of what motors we went over last time, so on and so forth. Or I can just call on someone. Let's see. Ashma, I think you were here yesterday, right? Do you want to just unmute and share on, like, what different types of motors there are, which ones are, like, more good for certain applications, so on and so forth?
I
Ashma?
had to leave early yesterday, but I think yeah, I had to leave early, so I don't know what you're talking about.
Okay, let me choose someone else then. Arjun, do you want to share?
I don't really remember. Oh, hello?
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 Can you hear me?
Yeah, I can hear you.
Okay, yeah, continue.
Yeah, I don't really remember what the different types of motors were. I'm pretty sure there was like, there was like the higher RPM ones, and there was like, more powerful ones, but I don't really remember exactly.
Okay. I think Linnea wasn't here yesterday, so I guess that just leaves either Manav or Sanjin. Do one of you guys want to share?
I think you talked about like the different types of motors and what there's. I think you listed examples of like their preferred use, like for like drivetrains or like different mechanisms, and you also gave us like showed us a spec sheet of like each price, power consumption, and stuff like that.
Yeah, that's good. Okay. Yeah, so it's okay if you guys don't remember it. We didn't spend too much time going over it. But you guys might want to watch over that recording because it might show up on your test. Just, But yeah, good job, guys. Not bad. Okay. So this is a lot of stuff, so we're not going to be able to go over like all of it in detail today. But here we have our electrical panel. So you can see there's a bunch of stuff here. This is not something that we usually worry about designing too much. But I do want to highlight this in particular because usually electronics and wiring, it's one of the things in a robot that can make it look really messy. But we did a really phenomenal job actually that year of packing everything together. You see everything is really clean and neat. Okay. Drew, do you want to talk about the climber a little?
Yeah, sure. So you guys see that hook at the top? Sonic, can you zoom into the... Sonic?
Wait, can you not see that again?
Oh, I think it's like lagging for me. Okay, yeah.
Okay.
Yeah. Okay. So, basically what happens is we had to, in the game, we had to climb this horizontal bar, right? So my best was to go right underneath that bar.
Is Drew vlogging for you guys too?
Raise
Yeah, he
our
is.
hook and then
Yeah, he is.
Drew, can you hear us?
No, he's lagging pretty bad.
Yeah. Okay. Well, Rishi, do you wanna introduce yourself and then like talk about the hook and climber?
Alright, yeah, so guys, my name is Rishi and I am the assistant design lead this year. So this part, like the black thing on top, that's like the hook. That's what we use for climbing. And we have to climb, I think, 10 feet off the ground. And the telescoping arm basically, and then it just shoots out and it grabs on, and then the robot like it gets winched up to the top. It's kind of hard to describe without like looking at like a video of it. But yeah, it goes pretty far tall.
Yeah,
It's
do you
like
guys
10.
want to talk about like this transmission system? You guys remember yesterday we talked briefly like we didn't talk about gears too much, but we did talk about chains and belts. So Rishi, do you want to teach them about like the sort of transmission system we have here?
Um, yeah, so once it reaches the top, I'm pretty sure a gear like shifts by a piston and it like gets locked into place. So that way it can keep expanding. But the telescoping arm, right? So it can't keep expanding. And then once it's locked into place, then it just winches up.
So if you guys look carefully here, there's actually a lot of different elements of like power transmission. So here we have gears, right? You guys are probably familiar with gears. We have sprockets here. If you guys actually look carefully though, here, like the motor here, because we want everything to be really nice and compact, here instead of chains, we actually used belts here. You see those there. So that's pretty cool. And then pneumatics, we didn't really touch on yesterday, but it's like pneumatics I think will definitely be on the more complicated side of CAD. So it's like where you use like gas powered stuff to move things along. Uh wait, is Drew back yet?
Yeah, I'm
Drew's
back.
not lagging anymore. Drew, do you want to tell them about pneumatics?
Yeah. So there's actually a video I found of the shooter, but basically, just like point to the hood up there. We can talk about that first. Yeah. So you guys see the hood, right? So from there is where the balls will come out. So you intake them from the ground, and they'll travel through the queue and go up the shooter, right? Because depending on where you are, or like in like relative to the goal, if you're closer to the goal, like the robot needs to have a higher angle for the hood, right? So you see the hood that kind of like arcs over the ball. If you're closer to the goal, you need to have a higher arc. But if you're farther away, you need to have a more lower arc. So to change the direction of which that hood is facing, we use pneumatics. So in this case, it was just like a two-stage pneumatic where you go from an on and off, like extended and contracted position. Yeah, so that's the pneumatic that San is pointing to. And the term pneumatic actually means like with the use of air, right? So you guys see there's like small tubes that are connected to like air tanks at the bottom of the robot, and like using our controllers, we can like release or like contract air to extend the pistons or to retract them. And that's how we kind of control the hood for the shooter to like change the angle at which we shoot. So there are other places where we use the pistons and pneumatics. So if you scroll down, yeah, you guys see that that whole like air valve over here that kind of tells us the air pressure and all of that things like that. So that's, you don't have to worry about that. That's taken care of with the fab team. But that whole system over there is like the pneumatic system that kind of controls the airflow through the tubes to where we need it. So what are the other places where we use the pneumatics and pistons?
We used it in the intake, but you can't see it in the photo.
Oh, right. Yeah, so even the intake, so we'll find another picture, but the intake kind of like goes in like down and up, so that it has two positions too. So if the pistons are extended, it would be down. If the pistons are retracted, it would be up. So I actually found like a couple of videos of the shooter and stuff like that. So do you want me to play that?
Yeah, you play those.
Yeah. Okay. So during testing, we kind of this is like the other side of the robot, right? So basically, what happens is at the bottom. Oh, here, at the bottom over here, this is the intake. So the balls will come in through here and they'll kind of like land over here. And the video quality is kind of bad, but if you guys see, there's like wheels lining this queue system, which rotate and move the balls inwards, right? So you guys see how they travel through the robot and then they go up using this like belt and pulley system. And because the hood angle is set to this degree, it will kind of go at a higher arc. If it was set to a lower degree, it would go a little bit more horizontally. So if you guys go that again. Basically, they start over here, and you guys see how the wheels are in contact with the ball. So basically, as they rotate, they'll move the balls inward. They'll go up this. There's like two belts vertically like in motion, which will also like make contact with the wall, pushing the ball upward. And because of this hood angle, they'll shoot at a certain degree. So that we had to kind of run trials in practice and see which hood angles like worked for us. But yeah, you can see how they like shoot balls. And then at the end of the field over here, there would be like a post where we are shooting the balls into. I haven't really looked at the other videos, but we can just see what they are. Okay, cool. So basically, you guys over here, so this is a flywheel mechanism. This is a shooter mechanism, but basically it's connected to a motor and it's just like three wheels and they're spinning, right? So obviously when the ball makes contact with them, they take the velocity of it. You have to like use math to calculate that, but the balls kind of speed up once they make contact with the wheels and shoot out depending on the degree of that hood. Yeah, so this is all like one mechanism. This is all the shooter.
Do you think I want to point out real quick? Drew, if you could pause the video. You guys see the little like green thing up there? That's the limelight. That's something our team uses a lot for computer vision, so you guys might be dealing with this at some point during the season. And for the flywheels, we have 3, and we also have these little like gold brass pieces on the side because a huge problem when we're shooting balls in real life is that there's friction, and when you're shooting at high speeds, there's a lot of friction. So we try to make the flywheel as heavy as possible, so every single time that we're shooting a ball out, our flywheel won't slow down substantially and change the trajectory of the ball. So to make sure that everything's really uniform, we always try to make the flywheels as heavy as possible. So our flywheel mechanism, it's like a couple pounds. It's pretty heavy.
Yeah. So that's the shooter again. Okay, so this wasn't actually part of the games for 2020. This was the innovation challenge we did for 2021. But we had to like perform tasks with the robot, so you guys can see like the robot like going through little obstacle course that was created. But it's just the robot in motion. If you guys can see, so this is the angle that we saw the picture that Sana was going through. So it's the same like electrical panel and then the climb and stuff like that. I think there's a picture of or video of the climb. Oh yeah, here we go. Okay, so basically this is the bar at the top. This is the bar we had to kind of climb, right? So the only way to kind of get there was to be directly underneath and extend upwards. So if you see every other robot, there are different mechanisms that are used. So this one has an elevator over here. This one has like a scissor mechanism. This one, I'm not sure what this is, but what we decided to do was a telescoping arm, because if you're going to be directly underneath it, a good way to have vertical extension would be a telescope. So you guys can see how there's like 3 tiers. One is widest, like that's the base, and then it gets a little thinner, like a telescope when you extend it out, right? And so we had like 3 stages, and the last stage had a hook on it. So if you guys can see, we kind of extended it completely and brought down the hook so it latches on. And then once we like contract that telescope, instead of lowering the telescope itself, it will kind of pick up the robot. So for the 2020 game, basically the end game task was to lift your robot off the ground. So that's what it's doing. And there's more like details to that, how we figure out how much torque and speed for the motors we need and how to extend that telescope and all things like that. But that's like the general idea of why we use the telescope and all. So yeah, so we went over oh, can you guys hear me?
Yeah, we can.
Okay, cool. We kind of went over the climb mechanism, which is the hook that we used to latch on. There wasn't really a good picture of the intake. I think we can find that later. But we saw like the electrical panel. We saw the shooter mechanism and the flywheel and things like that. So those are like one aspect of each category. So there's like flywheel is not the only shooter. There are other shooters. Like telescoping arm is not the only climb. So as we go through the season, we will introduce you guys to the different types of mechanisms in each category that we'll use depending on what game we're playing. But Sonny, do you want to go back to that video or do you want to continue on with CAD?
Oof. Okay, I think we should go back to the video, but also, Drew, next
Yeah.
time you share your screen, you might want to turn your video off because I think it's seriously limiting your bandwidth.
Okay, cool.
Yeah. You can screen share the video and show them that again. Actually, before that though, I'll put the picture of our robot back up. We just went over a lot of content, so there's no way you guys have absolutely no questions. Do you guys have any questions at all? Like any random things like, oh, what's that like panel there? What's that gear there? Just ask, guys. So, yeah.
Wait, I have a question. So the video that you showed of the robot in the garage, did that have the Swerve Drive train or was it something else?
That was a Swerve.
Okay. And also another thing is you mentioned the limelight. Is that like kind of like a sensor that was used during the color wheel thing or
Yeah, exactly.
what's that for?
Yeah, the limelight's basically like a camera. You can open up the feed and it literally just plays through like a camera. So we can use that for a lot of recognition tasks. So you could apply it to the wheel, like you said. But what we actually did is like we used it for aiming the shooter and stuff like that.
Oh, okay.
Yeah, good questions. Anyone else?
We actually like never developed that color wheel mechanism because we didn't think it was worth it. So that was actually used for the shooter itself.
More specifically for the limelight, we still haven't like fully like done it because there's some like issues with it. But yeah, no, it's meant for the vision tracking to aim the robot at the port, since no human can just like pull up and shoot it directly. Yeah, no, we used it during the infinite recharge challenges a lot, but I think it's black and white feed that comes through, so you can't really use it for anything other than just vision tracking of a light object or reflective object. That's why on the port you'll see
I
there's
think
like
Limelight
reflective
comes in
tape.
color feed.
Huh?
Limelight comes in color.
I remember when we were using it in the at-home challenges, it was all black and white, and then there's just like a green circle for the inner loop. And we normally use reflective tape and base it off of that. That's kind of what it is. So it's green. Green light tends to reflect the best when compared with all other colors.
Does anyone else have any questions?
Before you guys move on, I just wanted to ask everyone in this meeting, especially leads, to turn on their cameras again, just for, well, attendance purposes. If you guys can't turn on your camera because you're logged into a school account, that's okay. Try to use your personal email from now on. But if you like can't turn on your camera for any reason, just message the leads or send a message in the chat. If your guys' cameras are working though, they should be on right now.
Yeah, I think me and Drew are having Wi-Fi issues right now, which is why our cameras are on, but in the future. Guys, yeah. Okay, guys, anyone else have any questions? No other questions from anyone? Okay, that's fine. I will stop sharing my screen. Okay, so, I think now what we're going to do is me and Drew, we will start moving on to the actual inventor part of today's session because we did spend quite a while talking about mechanisms. So let me go ahead and get that started. Oh, something that I did want to mention today before I could forget. The CAD thing, I know we talked about the fact that like you guys are going to be having a test on Friday. So the test on Friday, it's going to test more of your actual like knowledge on stuff like vocab and presentations and mechanisms that we went over. But later in the season, so maybe after we do a West Coast Drive, after we do a gearbox, we're going to be testing your guys' CAD and like CAD skills as well, along with some, you know, stuff on like designing and strategizing. So I was planning on showing you guys some examples of that today, actually, after we do the CAD. Okay. Actually, Kush, can you go ahead and show your example first? I think my Wi-Fi's, my computer's being a bit slow right now.
So I'm pretty sure my example only makes sense after like you show the basic tools.
Okay, let me try to restart my audio. So no one has any questions about like all the different information that we showed you today?
Sonnet, by the way, Drew's computer just died. He texted me.
Okay, yeah, it's fine. We'll wait for him to come back in. Can you guys see my screen?
Yeah, we can see it.
Okay, perfect. So traditionally what we always do when we teach like extrusions and stuff is we do a snowman. So we're gonna do that. So you guys all go ahead and open Inventor and start up a new part. Okay. So we're gonna start by making a 2D sketch. And then if you guys have any questions at any point, just stop me. So go ahead and do that. To start, we're going to show you guys how to do so the snowman for this purpose obviously is not going to look too much like a snowman because I'm mainly just trying to show you guys how to use different 3D tools. So we're going to start off by making a body. I'll make it like 5 inches. Okay. Escape. And then, okay. So that's the body of the snowman. So usually at this point, I wouldn't really be able to tell you guys to do much more than, you know, draw another circle, draw another circle. But if we want to make it look 3D and pretty realistic, we're going to have to do something a little bit more than that. So what we can do is click a finished sketch, and then it'll bring us back to this. So you can see this is what our circle looks like. Now we want to make it 3D. So to make it 3D, this is when you would start using tools right here. This little Create tab under 3D Model. So in this case, we're going to do Extrude. So Extrude takes any like geometry that you made and instantly makes it 3D, like you see here, right? So for this, if you want to use Extrusion tool, you have to really make sure that you're doing like a closed geometry, so it can't be open. So like for now, you see that it works like this, right? But if I start another 2D sketch and I make something that's not closed, like for example like this, and I click Finish Sketch, it's not going to let me extrude it. Like I won't be able to select anything because it's not closed. So this isn't a valid geometry, right? But I'm going to go ahead and delete this. So if you want to delete a sketch, you can just right click and then click delete. Okay, I didn't realize it was muted. So what we're going to do next is we're going to use a tool called Project Geometry. So just to show you guys that again, you have this, right? And then we started you click Start 2D Sketch and you clicked on this face, and we start another sketch. We can do this Project Geometry. So what Project Geometry does is it allows us to take in the geometries of the previous one. Like for example, right now, Autodesk, when you're drawing a line here, Autodesk doesn't really recognize that like this circle exists. And since it's from a completely separate sketch, right? So in order to do that, you're going to go ahead and project geometry, and you're just going to project the geometry of this outer circle right here. And what we're going to do is we're going to make one single button. Or actually, I'll make 3. So make this a 1/2 inch button. Okay. And you can see it's still pretty free to move right now. You can basically move everywhere. So I'll go ahead and I'll take this and I will draw a line here. That's construction. I'm going to make a construction line here. Okay. I'll make that construction line tangent to the circle that we just projected geometry of. Also make this line horizontal. So now you can see there's like this faint line here. And I take this dimension and I'm going to dimension the distance here. I'm going to make that 1.5. Okay. Now I can use a rectangular pattern. Pattern it in the direction of a line that I need to define. So I'm going to draw another construction line. Just anything vertical, it doesn't really matter. Okay. So rectangular pattern, this circle in the direction of this line. And I'm going to make 4 buttons. Or maybe I'll make 3 buttons. I'm going to click OK. So I'm going to finish sketch. Now, does anyone want to unmute and tell me how I should make these buttons? What tool I should use?
You can use the hole that's next to the fillet button.
Yes, that's definitely an option. What else could I do?
For a quick second, could you go back and explain how to use the project geometry again?
Yeah. So here, you just click Project Geometry, and you just click on an edge or a shape from a previous sketch, and you just click on it, and then it'll turn green, or no, it'll turn green, it'll turn yellow. You can sort of see there's like a yellow line on the outside. Does that make sense?
When I click it, it doesn't turn yellow or green. Or yeah, it doesn't turn yellow.
Do you have 2022?
Yeah.
So what does it turn?
It just stays black. It shows a cursor, but it doesn't show a color.
Yeah, sometimes that's hard, but can you still do that stuff where you're like tangenting a construction line to it?
It doesn't show like a tangent, but I probably can do it.
Yeah, try it. And if you can do it, that means Autodesk did it. It's just not showing it for whatever reason. But if you can't do it, then you can stay after and we'll work it through with you. Okay, yeah. So like Mahima said, we could use the hole. But in this case, we're not actually going to use the hole because for whatever reason, our team has never really had the habit of making holes like this. But for holes, you don't even need holes are handy for a lot of different things, actually. They allow you to have a lot of customization, so most engineers who use Autodesk actually use holes pretty regularly. And you just need a point, so you don't even need to do anything like the circle. But what our team has always just done, it's not necessarily good or bad, but it's just the way that I was taught, and I think the people before me were taught, is we've always just used the extrude. So just like we did right there, you do the extrude, right? But obviously that's not really what we want our buttons to look like. What we're actually going to do here is you can flip this. And if you flip direction, you'll notice from down here, it went from join to cut. So what it's going to do is it's going to cut some holes in the shape that we just made. So do you guys see now how like it sort of looks like a button a little bit? So is everyone here? Okay. And if I want to make this look a little bit more like a snowman, I can change the color and look, appearance of stuff like this. So if I want it to look like gold, I can just click gold. And you can see that Autodesk will change stuff. If I want it to be gold, but I want the outside to look like something else, then I could do something like red. So now it's red, gold. Or I can make it oak, you know? Anything like this. So you just sort of play around with this. Right. So there's just a lot of really fun stuff. And then there's titanium. So our team doesn't actually usually go through too much effort to like make sure everything is like exactly what it is. But when you're running simulations in an Autodesk, this is pretty important. That's just something for you guys to know. Something else I don't want to point out is you guys probably noticed when I made this extrusion. Let me just delete it. I had to don't delete the consume sketch and features. I had to like manually select this circle. I had to manually let me zoom in. Okay. I had to manually select this circle and this circle and this circle. But since it's only 3, it wasn't that big of a deal. But if I have like 50 circles that I just patterned and I want to extrude, that would be a nightmare. So what you can actually do in Autodesk that's super cool is you can pattern 2D sketches, right? Like I showed you yesterday. But you can actually also pattern 3D stuff. Like for example, you see the pattern tool here. If I just click circular geometry, just for example, I do this, and like for the rotation axis, I do something like this. I can make circular patterns, and I can do the same thing for like rectangular patterns as well, if I wanted to. Something else that you can do with extrusions is you can right-click, click Edit Feature, and go back and edit it. Like for example, if I don't want it to be 1 inch, I want it to be 50 inches, I can go back. But I can go back and also, oops, not what I want to do. Okay, I can go back and change it so that I can like select. If I initially only selected one, I can go back and edit and select all of them if I wanted to. So that's a short little overview of extrusion. You can go through and rename this stuff. You can go through and rename this stuff too if you right click and then or not like this. You just like double click this text box and you can like backspace and rename it. But we don't ever do that because it's not really necessary usually. And if you hover over it, you can see what the extrusion did. Like for example, you can see that did the cuts, that did the outer geometry. Any questions?
How did you change the material?
Say it again.
How did you change like the material of like the?
So up here, you guys see this?
Oh.
And then you also have this to choose look. There's also color wheel, which we'll be showing you guys later. That's a good question. Anyone else?
So at the top of the drop down, there's like 2 of them. Right? So one is for the actual material, and the other one's for the appearance. So like you should make sure that both of them stay the same.
When you change the material here, Autodesk will automatically change like this here, unless like you did something to override it. And then if you did something to override it, but you don't want to override it anymore, just scroll all the way up and click Clear Override. And then it will just be exactly what it's supposed to be. Okay? Okay, so there's a couple more tools that I have to show you guys today. I'm not going to have to show you guys all of this because it comes with time. But something else that you guys will be doing. So let me start another 2D sketch. Okay, so I'm going to go ahead once again, project geometry right here. So what we have here is a circle, right? So I projected geometry, and you guys can see it. You can't really see the the projected thing that I just did, but there's like a faint yellow circle back here that you can sort of see. So what I'm going to do here is I'm going to draw just the head. So this is a simple snowman. There's only 2 parts. So let me make this 2.5 inches. Okay, this is good. I like it. So this is going to be the head, and I'm going to go ahead and make this tangent. So how I'm going to make this tangent is using the tangent constraint, right? So zoom in, tangent. But this is so far what this can still move around, right? It can revolve around the circle, but that's not what I wanted to do. I'm going to draw a construction line. Okay, and I could constrain this construction line, so that's not purple either, but it doesn't really matter that much. You can switch into the constraint and make sure that those 2 are touching. Nope. I'm gonna do coincident constraint and do click this dot first, and then. Okay. What I will do then. Let me try this one more time. Okay. I guess I will have to lock this down then. So for this, in this case, you could either fully constrain it by looking, at the origin back here, and like making this attached to the origin, and then giving this a fixed dimension, like this, and then it's black, and then you can't move it anymore. So you could do that to make sure that everything, and you can put those two, and you can see now the circle is black too. Okay, so the circle can't move. But this time, instead of making a snowman like this, because that's not really how snowmans look like, we're gonna make it a sphere. But making it a sphere is actually a little bit harder, right? Because it's not like a straight up extrusion. So you can't just use the extrude tool like I just showed you. So in this case, what you have to do is use something called the Revolve Tool. So what I'm going to do is I'm going to split this into two circles so you can see I drew a line in the middle. And I did not use the construction line. I did not use the construction line. Repeat, I did not use the construction line. This is super important. I'm going to finish sketch and click Revolve. So what the Revolve tool is, it revolves a profile around an axis. So in this case, I'm going to click either half, and what it's going to do is, after I select my central axis, it's going to revolve it around and it makes a sphere. Does that sort of make sense to you guys, how the Revolve tool works? And for this one, you can't really customize too much besides the angle. Like if you only want, if instead of 360, I just want it to be 180, right? That's like the main thing that you can change. But otherwise, you can't really change, the number of inches or anything like that because everything is already predefined. But that's the Revolve tool. And you guys will be using this a decent amount. Does that make sense to everyone?
Wait, can you do the whole sphere process again?
Yep. So, did you get this, Mahima?
Yeah.
So you're going to click Revolve. You're going to click the geometry. You're going to click the axis. You're going to click OK. Sometimes they'll give you this, and usually you can just ignore it and it'll be fine. Does that make sense to everyone? So you can, besides making circles like this, spheres like this, you can apply it to making other stuff like cylinders, a lot of cylindrical things basically. So for a sweep, loft, and coil, you guys might use this. But I think the last thing that I want to show you guys how to do is a sweep. So let's just say I want this to have like a little thing going around it. So I'm going to project the geometry here of the circle again. I'm going to draw two rectangles. So one's on the circle here. I'll make it 1 by 1. Oop. Okay. And then I have something here, and I'll make this 1 by 1. We have this, and it can still freely move. So so Autodesk figured out that you wanted it to be tangent, but it didn't really figure out like where exactly you wanted it to be tangent. And honestly, that's fine for our purposes. Now I want to make a sweep tool. So what sweep does is sort of hard to explain until you've seen it in action before. But what sweep does is it will sweep a geometry from one to another place. So you can click sweep, you click this. Oh, no. Let's do loft. You click this. Let me redo this. Actually, let's just do it like this. Click sweep here, and for the profile edge, we could do something like this. And then this would require me to make a separate sketch. Okay, fine, I'll do it. Also start a 2D sketch. Yep. And yeah, okay. Setting this up might take a little bit too long, And since we already spent a lot of time, I'm not going to go over that today quite yet. We will be going over sweep, loft, and coil next time we meet. One final thing that I want to show you guys is the fillet. So if you guys see right here, everything is super duper rough, and we don't want that. So what we can actually do is just like collect a bunch of edges that aren't smooth and round them out. And you can work here, like roll along sharp edges. And there's a lot of different customizations that you could do here. This setup is a little bit different than 2021, for those of you guys who are familiar with that. But for the, you can just select them and round everything out for you. You click OK, and you see now that it's rounded. So that's fillet, extrude, and revolve. Anyone have any questions? And then also I went over a little bit of the patterning in 3D. But does that make sense to everyone? Okay, sounds good. So now I'm going to go ahead and Kush, you can show your demo, and we will talk a little bit more about the strategy challenge that you guys will be doing after bootcamp.
Alright guys, I'll share my screen. Give me one sec. Alright. Can you guys see my screen?
Yeah.
Alright, cool. So what I'll be doing now is showing you guys how to make a sprocket, which is very common in robotics. It's basically like a gear, but instead of gears meshing with other gears, it just connects with chains. So I'll be making a sprocket, and I'll be using a lot of the stuff that Sonnet just talked about. And I highly encourage you guys to try to follow along. I'll be going really slowly, and I guess feel free to ask me if you guys have any questions. Okay, so first I'll start out by making a new 2D sketch.
Yeah, guys, just briefly for homework, besides doing the assignment that I'm going to tell you guys later today, you guys are also going to be expected to submit a picture of like what Kush did, but with the customization, like changing the material so we know that you did it, and we'll make and then you guys can all send that to Drew's email. But yeah, we'll be checking in with you guys for this and the homework. Yeah, go ahead, Kush.
Yeah, feel free to ask any questions and like stop me, okay? Okay. So I'll start off by starting on the XY plane. For this sketch, or for this sprocket, the actual dimensions will matter, so make sure to select the XY plane. Alright, so once I want to do that, so the way I'm imagining this is that the sprocket will have some sort of hole in the middle where maybe an axle or something can go through. So I guess I'll start off by having a rectangle, and I'll use a 2-point center rectangle, and I'll start from the origin. Okay, yeah, I'll start from the origin. There we go, okay. And let's make this, I don't know, 0.5 by 0.5. After that's done, press escape, and you should have a black square. Once that's over, I'm going to imagine my sprocket being somewhat circular in shape. So this will be where my axle goes through, and on the outer edge, I'll have a circle. So click the circle tool, start in the middle, and let's make this 5 inches in diameter. So press enter and press escape. So right now you guys have something looking like this, with a square in the center with a circle on the outside. So once that's over, I'll press exit and finish sketch. Is everybody here so far? Yes, no. Okay, I'll assume you guys are here. Alright, so once that's over, I'm going to extrude this. So I'll press extrude. And I want to make sure to extrude only the part that's outside of the square. So outside of the square, but inside the circle. So this part right here, see how the square is not highlighted. So I'll press that, and let's see, I want to extrude this, let's go 2 inches. And I want to select this one, so the tool that says symmetric. And all that means is that the extrusion will happen on both sides. So it won't go out on one side or the other, but it'll get 1 inch on both sides. So I'll press that, and then press OK. Alright, so once you guys have that, you should have something that looks like this. Is everybody here so far?
Feel free to just like shout out that you doesn't
Yeah.
hear you.
Alright, I'll assume you guys are there, unless you guys have any questions. Alright, cool. I'll move on then. So then next what I want to do is add sort of the projections that come out from the center of this, I guess, center of the sprocket, because, you know, all sprockets have these projections that come out. So first what I want to do is put this in a 2-dimensional sketch. So the way I'll do that is I'll press origin, and this will give me all the different planes of this, I guess, geometry or structure that I have here. And I want to select the XY plane right now. Right, and see how the XY plane is going through the center of this, I don't know, cylinder, I guess, right now. And so, since it's going through the center, what I want to do is, let's see, let's move it like this. Alright, so I want to press this, left click, and press New Sketch. Alright, so now I'm back in 2 dimensions, and I want to add a sketch that adds, I guess, my sort of projections. So the way I'll do that is by using a line tool and some arcs. So this is something we covered in the yesterday. So I guess we'll be using a lot of things that we used over the past 3 days. So I guess it's good review as well. So I'll start off by clicking the line tool. And I'll make sure to press somewhere on the edge of the circle. So press like that. And then let's just go out a little bit like this. I guess just press or left click your mouse. And then hold your mouse, and then makes, so the way this works is that you want to hold your mouse so it makes some sort of arc, like this, and you want to stop the arc when this dotted line shows up. So as soon as this vertical dotted line shows up, you want to stop it there, like that. And then you want to continue to the edge of the circle again. And this will be sort of our projection that comes out of the center, and we'll make the sprocket. So once that's over, we want to make sure that all of this is, I guess, black, and make sure it's fully constrained. So I'll press escape, and the way I'll do that is using a lot of the constraint formulas. So over here I'll press constrain, and I guess the first thing I want to do is make sure this line is tangent with the arc, right? So I'll press constrain, and I'll press tangent, and I'll press this line and this arc. Alright, cancel. And then I'll do this with this one as well, this line and the arc. It says it already exists, which is pretty good. Then what I want to do is make sure it's symmetric about this middle line over here. And so the way we do that is we'll create a construction line. So press escape, and then press format, and press this button over here that says construction. Press that, and then you want to create a line. We can make the line start from the origin and go, I don't know, somewhere here. That's good. So notice how this line is a dotted line, so it's not going to be part of the actual sketch or the final diagram. So once that's there, I want to go back to constrain and use the Symmetry Tool. Once I selected the Symmetry Tool, I want to press this line, and then the center line. So notice how everything became symmetrical with each other, and that's kind of what we want, okay? So after that, press escape. And I guess I'll just ask, is everybody here so far? Any questions? Okay, seeing none, again, feel free to ask if you guys have anything. Alright, so once that's done, what I want to do is maybe change the angle between these 2 lines. And so the way I'll do that is go to constrain and press dimension. And after I did that, I'll select the 2 lines, and you'll see an angle that comes up. Let's say I want to make this, I don't know, 15 degrees. And you press enter. Alright, then you can escape that. And so now we have the projection that comes out of the central circle. And so now what we want to do here is extrude this. So we'll press finish sketch. And you see this projection coming out of the center. And now we just want to extrude this to both sides. So it's basically the same thing we did with the circle. Want to press create and extrude. And then you want to make sure this part is highlighted. There we go. So obviously this doesn't look right. We probably have to adjust it. So first we want to make sure it's symmetric across this center plane. So I'll press symmetric. Alright, and now I don't think 2 inches looks good. That looks kind of ugly. So let's do, I don't know, 1 inch. Yeah, 1 inch looks good. So do 1 inch and then press OK. Alright, so now you guys see this. We have the central circle, the central cylinder with a protrusion going out of that. So what we'll want to do from here is make sure this protrusion goes, across all, across, the entirety of the circle. So we have a protrusion coming out. And the way we'll do that is using the circular pattern. But before we do that, I want to make sure we fillet, I guess, all the edges of this sprocket. So the way we'll do that is, I guess, go back here and press the modify tool and then press fillet. Alright, so once you press fillet, you just want to select the edges you want to fillet. And this is also really good practice because in general, when you're designing something on CAD, you want to make sure to fill out your edges because the edges could be really sharp once they come out of the machine. So it's always just a good practice to fillet. So I guess I'll press my sides here. I'll press that. And I'll try to get all the sides that I made for the protrusion. Alright, I think that is everything. So then I'll just press OK. And so now you guys see all the edges are rounded off. And so now what I want to do is make sure this protrusion comes out.
Wait, can you do the rounded off thing again? Like the last 3 steps?
Yeah, so the fillet, right?
Yeah.
Okay, so what I did is that I just I'm in the 3D model mode right now, and then I pressed modify, and then in modify I have the fillet tool. So I just pressed that, and once I press the fillet tool, the different edges will light up. Since I've already filleted everything, I guess I haven't filleted this center part, but you see how the edges light up green? And so those are the edges you want to select to fillet. So I just selected all the edges that I have. Did that make sense?
Yeah. Thanks.
Yeah. So once you, I guess, select them, it'll appear blue. And then after you press OK, everything will be fixed. Alright. So now everything's filleted, and now I want to make sure this protrusion comes out on all the different sides. So the way I'll do that is using a circular pattern. So press pattern, circular. Okay, so what I want to do is first select what I want to be, I guess, the pattern. So I'll select everything here. Yeah, make sure this part is blue, the protrusion part. And then I want to select my axis of rotation. So I want this to rotate about the center of this cylinder. So I'll just press rotation axis. And let's see, I'll try to go here and press the center. I guess the center is not coming up. Okay, so I'll press cancel for now. And since the center or the origin is not showing up, I have to find some way to create the origin. So I'll do that by creating construction lines, I guess. So go to, okay, yeah, so what you want to do is press this face and select this button, or you can left click and say new sketch. And what we want to do is create a few construction lines. So go to format and select the construction button and then create lines. So I'll just go from here to, wait, hold up. Okay, yeah, here to here. I'll zoom in a bit, yeah. And then I'll go from here to here. Alright, and then I'll press escape. So now I have 2 different construction lines, and hopefully I can be in finish sketch. And now hopefully I'll be able to select the center as my axis of rotation. So let's go back to the circular pattern. Select that, and maybe let's go a bit more. Yeah. So select your protrusion, and then go to rotation axis, and then go.
Yeah, Kush.
Yeah.
So A, construction lines are get ignored, remember, when you're outside of the sketch, and B, when you're doing rotation axis, a point isn't really an axis. So what you can do here instead is just select the circle outside. Like, you know, the circle of the body?
Like
Something
this.
that. Yeah.
But then I'll rotate around. Will that work? Okay, I guess I'll try it.
So
Okay, works. Yeah. Okay.
yeah.
Yeah,
Okay.
yeah. So usually you can do something like that instead.
All right. Yeah. Cool. So that was pretty much unnecessary. Don't create those construction lines. You can select a circle as well. Okay. So once you do that, you'll see these green parts coming out, and that's where the different projections will be. I guess I can select 10. I guess for how many projections I want. So this will be a 10-tooth sprocket.
Wait, Push. Before you do that, click escape. And then like go into like isometric view.
Like, what do you mean? Okay.
Yeah, this is good. This is good. And then do the circular pattern again. Okay, so like, select your protrusion, right? And when you're selecting your axis, just like hover over the circle. Yeah. That square there. Go over the square.
Right, like this.
Just like hover over that circle. So like, did you see that axis come through that last time?
Like this one, yes.
Yeah. There you go.
Okay.
I think that's the edge. Okay, never mind.
Dude,
But
that's
usually,
not center.
Yeah, that's the edge.
okay. So then just click the circle.
Yeah. That
Yeah.
works.
Okay. You see
Yeah.
that highlighted axis over there?
Yeah. That's
That
what.
dash line. So yeah. So if you select the circle, it will like revolve around the center.
Yeah.
So you
I
don't have to
guess-
like make your Okay.
Alternatively, I suppose you could have also selected the z-axis, but yeah, both of them work. Okay, yeah. So once you've done that, I guess select 10 for how many you want, and then press OK. All right. So I guess what copied was only the actual protrusion and not the fillet. So I think we can do it again. So pattern, circular, and I guess this time make sure to select the fillet specifically. Like that. And then same thing, axis will be the circle part right here. And then select 10. And yeah, that should work. And so now, yeah, now everything will be filleted. Alright, so now we have basically something that looks somewhat like a sprocket. You have 10 different teeth coming out. At this point, I don't know. I mean, this is basically done. I guess we can try to add a revolve somewhere here. Let's say I want to like cut a bit out of the teeth. Like, yeah, let's say I want to cut a bit of the teeth out. I can use the revolve function to actually do that. So the way I do that is, go to the X, so on the side, it'll say origin, go to the XZ plane, and then say you want to create a sketch on the XZ plane, like that, yeah. And so now what you want to do, you're in sketch mode right now, select project geometry, and select this side and this side, alright? So after you do that, escape project geometry, and you can create a rectangle. Let's use a 2-point rectangle. And then let's see, let's say I just want to cut this part out, like that. Alright, so I have a rectangle. Right now you guys don't see it because it's technically inside of the protrusion, since we cut halfway. But there's a rectangle inside, and what we'll do is we'll eventually revolve that rectangle all around the center. So whatever's gonna be in the path of that rectangle will get cut out. That probably didn't make any sense, so I'll show you guys what I mean. So press finish sketch, and then go to create and press revolve. And I think it's already, I think since it's the only thing that can revolve around, it's already selected, so don't do anything there. And then, let's see, select axis. So for axis, once again, just select, does the z-axis work? Oh wait, that works, okay, yeah. So for axis, you could have just selected a z-axis, and that does the same thing. So right now, you'll see a circle that kind of goes all the way around. and that's what the revolve function basically does. And since it revolves around and it's green, it means that I'll be adding material to the actual geometry. But what we want to do is actually cut out material. So instead of saying join, you want to press cut right here. And now you'll see this will become red. And now you'll kind of see what the final sprocket will look like. And once you guys have all of that in place, just want to point out this blue rectangle right here is the original sketch we made that we revolved all the way around the center. After that's over, press OK. And yeah, that's basically it. So that's your sprocket. I guess at the end you can also change the material. So I don't know. We can make it titanium. Nah, there we go. I think it'll take, yeah, there we go. So yeah, that's your finished sprocket. Any questions?
When you made like the rectangle to revolve around the sprocket, I didn't get that part. Can you go over that again?
Yeah, for sure. So what I basically did there is I wanted to create a rectangle. So you have to kind of think backwards, right? Like I want this part of the like protrusions to get cut out, right? So in order to do that, I probably need some sort of rectangle that kind of revolves all the way around, right? And so the key step here is to pick the correct plane to actually create that rectangle to revolve around. So the correct plane here is the XZ plane. So if I select that and I say, so if I select XZ plane and I press this button over here, this button right here is just new sketch. So I press that button. You'll see now I'm kind of looking at a side view of the sprocket. So now, like what I did last time is I created you guys can see my cursor, right? Yes, no?
Yeah.
Yeah, okay, so what I did last time is I created a circle, or a rectangle right here, and that revolved all the way around the sprocket, and it cut it out, right? So the key step here was to make sure I'm on the XZ plane, and I'm creating a rectangle over here that I'm revolving around the center, right? Which is this axis right here, right? And once it revolves around, I can either add it to the sprocket, or delete that material from the sprocket. And what I want to do is delete it. And then I basically got this shape. Did that make sense?
Yeah, that.
If it still didn't make sense, I can like go over it again.
Yeah, I don't really get how you like placed like where you made like the rectangle and how you placed it.
Okay. I wonder if I can like Control Z and like see if I can just do it again. Okay, yeah. So I'm over here, right? So what I did is I made sure to go into the XZ plane, right? So now the XZ plane is highlighted. Then I pressed New Sketch or Create Sketch, right? So that'll take me to the side view. Does that make sense so far? Yes? No?
Yeah, okay, yeah, that makes sense.
Alright, cool. So once you're there, what you want to do is project the geometry. So you'll go to sketch mode and press project geometry. I already did this, so this side will be highlighted and this part, I guess, will be highlighted like that, right? So these will appear yellow. And then after you project the geometry, just press escape, right? So now, and basically, by the way, the reason we project the geometry here is because we can't make a rectangle, a two-dimensional rectangle, on a three-dimensional surface, right? So we have to project the geometry. And that's why the rectangle actually goes through the projection, if you can imagine that, right? So now all I want to do is create my rectangle. So I go create rectangle. And for this instance, I want to use a 2-point rectangle since it's a bit more convenient. So I press that. And I just select where I want to start and end, like maybe right around there, like that seems good, right, like that. And then I just press. And so right now you won't actually see where the rectangle is, and that's because it's inside the protrusion, right? But you can just imagine how there's a rectangle that you already made over here. You can kind of see the green outlines. And what we're going to do after that is you have a rectangle right over here, right? That's going to get rotated around the center axis, the z-axis, and get rotated all the way around. And after that's over, you're going to have, I guess, a circular, I don't know, like a torus, right, that goes around. And you can either add that material to the sprocket or delete that material. In this case, we wanted to delete it. So the way we do that is go to the pattern tool, or not the pattern, oh wait, so first we have to finish the sketch. And then we go to 3D model, and then we use the Revolve tool, right? So usually when you're using the Revolve tool, you have to select what you want to actually revolve. But since this rectangle is the only thing that could get revolved, in this entire thing, it automatically gets selected, right? So Autodesk Inventor is a bit smart like that, right? And so since that is already selected, all we have to do is choose the axis we want to rotate about, right? So we want to go here and say select axis, right? And in this case, we want to rotate around the z-axis, right? So that axis is selected, I think. Should be selected. Select profiles. Okay, there we go. So yeah, so select the profile you want the rectangle, and then select the axis, which is the z-axis. And after that, this rectangle will kind of get revolved around the center, right? This is what this green, I guess, torus you see, that's what gets revolved, right? Does that make sense so far?
Yeah, I got all that.
Alright, yeah, cool. So then the last step here is just that, do we want to add this material, or do we want to cut out this material? So in this case, we want to cut it out, so we'll press cut, right? And this will be appearing red now instead of green. And then we just press OK, right? And so if you look at the sprocket, you'll see that the part is cut out, right? Does that make more sense?
Yeah, I got all that. Thanks.
Alright, cool. Yeah, and then after that, you can like change the material to whatever you like. Diamond. Alright, does that make sense to everyone? Any questions? Alright, just like as a quick review, some of the tools I used. Obviously I made a 2D sketch. I used the Extrude and Revolve Tool. I also used the Fillet Tool. Yeah, and those are basically the main tools I used, I think. Fillet, Revolve, Extrude. Yeah, those are the main tools I used. And I also used circular pattern. Yeah. Does all that make sense? Alright, if there are no other questions, then I'll stop screen sharing.
Okay, guys. So thank you, Kush, for the really nice demo. So I think the final thing that I really wanted to talk about today was the design challenge, which you guys will be doing probably a little bit later. So I guess just to start off, I'll show you guys what the design challenge might look like. Okay. So let me pull it up. But yeah, just as a reminder, actually let me briefly talk about homework first. So for homework, besides just doing besides sending Drew an image of the sprocket that you just catted along with Kush, with a custom like material, like changing the color or something so we know that you did it, we also want you guys to CAD something else that sort of demonstrates, you know, that you learned. So I think today what we can do, I think we did it a couple years ago, is we're gonna have all of you guys CAD a 3D superhero logo. So this could be anything, like it could be a little Avengers logo, something with the A, or something like that. So any superhero logo. And we also want you to submit a picture of that to Drew as well. So don't like spam his email, just have 2 of them all at once. And then we'll go over those tomorrow. So everyone here should go ahead and submit the customized sprocket that you built today with Kush, and also the one that you, and also the superhero logo. So for the superhero logo, don't make it too simple. You know, make it like moderately difficult so we know that you are pretty familiar with what we're trying to get you to do. Okay? Does that sound good?
So like all you have to do is like search up like a picture of a superhero, like Flash will have like lightning bolt, or like Superman will have that S, right? So take any superhero, like anything in that like area, and just like replicate that in CAD. There's their logo, and yeah, that's just the logo.
Okay. So something that I wanted to mention. So aside from just CADing, something else that's a huge part of design the full name is Engineering Design and Strategy, right? So strategy, studying other people's robots, is also a huge part of what we do. And we haven't gotten into that too much right now because we're trying to just focus on letting you guys work with CADing everything and learning how to use Autodesk because it is pretty difficult. But what usually to assess strategy, since that's a little bit harder, what we do is something called the design challenge. So I'm showing you guys an example of what I did when I was a rookie. So this is a design challenge, and the design challenge, essentially what we do is we have you analyze one of the past games, and it's usually a pretty thorough analysis of it. Like example, mine was 12 pages. So what you have here is it's just a design challenge. So we'll assign you a specific FRC game. So this is pretty far into the future because we haven't taught you guys how to analyze FRC games yet. But just to keep this on your horizon. So we'll usually start with something like a scoring breakup. We haven't really gotten to this yet, so don't worry about it. But the main thing I do want to point out with the design challenge is that you guys have to be able to distinguish between the different mechanisms. So sort of like what we did with our analysis when we went over drivetrains together, you have to say, oh, for this game, I think we should use this drivetrain. What is this drivetrain? So this chassis is, what is an 8-wheel West Coast Drive? Why is the 8-wheel West Coast Drive good? And then you also have to analyze the pros and cons of all the West Coast Drive. So why would this be good? Why is this bad? So you have to do that for all the different mechanisms that are going to go into your robot. And this is basically the exact same pipeline and process we're going to do in the real game. So in the real season, so once the game is released, we'll go through and analyze what's good, what's bad, and why. So also like for different mechanism, right? So we talked a little bit about the intake today on our 2020 robot from the Hammerheads. So we can see, oh, this is what I think is good. Pros, cons, reasoning, description. So mechanism 3, flywheel, right? So we did talk about the flywheel today. So here you can see for their flywheel, they also had something similar, right? They also had 3 wheels, which we saw on our robot. And then also the ball, which allows it to shoot out. This is the flywheel, why it's good, why it's bad, what it is, reasoning. So, and then this was their climbing mechanism. Usually FRC games like to have a climbing mechanism somewhere in there. So here they did something like a combination of like a elevator and like a foldable arm. So that's what we have here. But I just wanted to put this out just so you guys on your radar, so you guys know that this is coming up soon. Okay? So this is the design challenge, and we will be releasing more details. Usually we make you guys do this around December, so we do still have a couple of months. But yeah. Okay. So I think that's all I have for that. Drew or Kush or Rishi, is there anything else that you guys want to share?
No, I think that's it. Do you guys have any questions about the homework assignment? Or anything Kush covered or Sami covered today? Okay. So like you guys did today in class, where you guys sent me a picture of the email. You guys can do the same thing with this assignment. With just like 2 of them actually. One which Kush covered in class, the sprocket and the superhero logo. So before class, if you guys can send that to my email, that'd be nice. And yeah, you guys have anything else? Okay, so that's it for today. If you have any questions, you guys can stay back, or else we're done for today.
Yes. So briefly, we're going to just be wrapping up the CAD stuff, and we'll probably be reviewing some material for tomorrow's test, the day after tomorrow's test, so Friday's test, and going over less CAD stuff and more starting to get into the strategy and stuff, game analysis. Okay, yeah, thank you everyone. You guys are all free to go now.